that more. All right. Cool. So can you all see my screen again? See Ludo and Brittany have just joined?
Yep.
All right, cool. So just in this sprint here, week 29, week 31, we got Chain D refactor in review. I think that's just waiting for me still, right, Ludo?
Correct. Yeah.
Okay. I'm just unclear on how to interpret what's being stubbed and what's not. So I guess I'll just circle back to that with y'all async.
Sounds good. Yeah.
All right, cool.
Yep.
Then we got this one here, incorrect bad nonces. I've been going back and forth with Pascal about this. I think it's fine. I mean, I can go ahead and ask him to merge this.
Yeah, so he won't be able to merge it.
I mean, he doesn't need to work on it.
Okay.
My mistake.
Yeah. So, yeah, if you approve it, you can just merge it. I think it's probably the way to do it.
Cool.
Yeah.
Go ahead and do that after the meeting. All right. This is still in progress. I mean, it's not in progress anymore. It's in review. I think it's just waiting for both y'all's review.
Yeah.
Cool. I sent a couple PRs this weekend. One of them is an update of the IP discovery protocol. It turns out the two-phase process that we originally had, where you would ask a random node for what it thought your public IP address was, and then try to connect to yourself on that IP address, doesn't work. Specifically, the second step does not work at all. Something to do with how NATs deal with you trying to talk to yourself, even if you're doing port forwarding. Not quite sure why, but it seems to be a problem that's not specific to us, but also just generally applicable. I think full cone NATs don't do this or something, or a lot of consumer hardware realizes that, oh, you're trying to connect to me on my public IP address, I'm just going to NAC you. So this PR just takes that out. Instead of asking a random peer, it'll just have you ask one of the initial peers that you listed, i.e. the seed node, and it will just run with that as its IP address.
Are we introducing some kind of single point of failure with this approach? And so if so, should we just say that we don't support miners mining behind the NAT? Like, if I don't have a way to verify that the IP address that I feel like it's a half-baked feature, and can it be like a point of failure, or can it be used as a attack vector somehow?
It's a good question. To answer the first question about mining, no, it doesn't stop you from mining, because you can just send the block to any publicly routable node after you mine it, and it will be replicated across the peer network, and you don't need a public IP address for that. Second, regarding the need for public IP addresses, this is necessary if you want to be able to serve blocks. It's not necessary if you want to be able to send transactions or mine them, but if you just want to serve them. And I do think it's a good idea, even if whatever measures we put in place don't work 100% of the time. I think it's a good idea to try to maximize the number of replicas that are running out there without forcing users to have to take on any extra work to make that happen. An alternative to this could be we just don't do this at all, and we say if you want to serve blocks from your home network, you'll have to set up port forwarding, discover your IP address, set up dynamic DNS, and do a whole bunch of extra work. And by doing this, we save users that step, and in doing so, we make more public replicas. All they have to do is set up port forwarding.
Right. So I think, yeah, it's okay to do this as like kind of a heuristic. But the way that I think about this is that like port forwarding is already like setting up port forwarding is already like a pretty big burden for like a home user. Like setting up port forwarding on your router is already like a big step beyond just doing cargo run stacks node.
Yes, it is.
And so requiring that they also set like a configuration option for their IP address might be easier or more direct than a setup that has like a failure condition that they might not even be aware of.
To be clear, this doesn't stop you from doing that. In fact, if you set a public IP address in the nodes config, this protocol never runs.
Right. I'm just thinking about like in our documentation, right? Like it's one thing to say set up port forwarding and then like either get like the DNS pointed at your computer and use that as your configuration, or set your public IP address in the configuration and then run the node, right? Like this is like a process that is just like one direct flow. It's like set up port forwarding, determine your publicly routable address, and then configure it. The alternative where we try to figure out their public IP address for them has this like failure scenario that is like hard for them to actually determine. Like it's hard for a user to know when their public IP address that the node tries to figure out itself has gone wrong.
I don't know if that's really true, because no matter what you do to set up your node to serve, the last thing you're going to do is verify that it actually can serve. So by that, I mean, you'll whip out your cell phone and you'll try to curl v2 info from your public IP address. So you'll figure out really quickly if it's the wrong IP address.
Yeah, I think that's true. So yeah, I don't know. I think
I agree it's half-assed right now. Like what we should be doing, and I didn't want to spend too much time doing this because it is a kind of hairy problem, is doing something like UPnP, where you can automatically have the service register itself with your router, and then you can ask for port forwarding to happen automatically. I think Bitcoin actually can do this these days.
Interesting. Yeah, we should just create an issue, and we could even tag it as help wanted. Because like if somebody wants to set up a UPnP or add support for a UPnP protocol to the Stacks node, like that's actually relatively separable as a problem from everything else that's going on in the Stacks node.
True. I can go ahead and do that.
Cool.
Should I withdraw this PR then, or should I just leave it in place? Because like even if you don't want this, at least it cuts in half the amount of code that works on this problem.
Yes, I agree. Like we should act like this PR, I think is a good idea. And then like whether or not we want to go further towards removing this or changing the way that it works is a separate problem. But I think that like this is just, yeah, objectively an improvement on what we're currently doing.
All right, cool. I also implemented another PR this weekend that implements the burn block height clarity native variable. This was blocking me because the clarity lockup state in the boot code depends on this variable existing.
Yeah, makes sense. Yeah, I took a look at it this morning and it looks pretty good to me. I'll do like a formal review after the call.
Sounds good. Okay, in progress. We got the implement proof of transfer DB for chains coordinator.
So this one is a bit fuzzy.
Yeah.
So I saw the conversation that you had with Aaron mentioning the removal of the POXDB. Yeah. So yeah, I think that maybe we can take some time after to catch up and to come up with a plan.
Yeah, sounds good. Just talk about this more after the sprint review.
Yeah.
Yep.
All right. I started working on this on Friday. So far, it's just Clarity code to implement the lockup. mapping that maps principles to a bunch of extra fields about what clarity state is locked up and not. But I guess we're going to talk about this later in this call too.
Yeah. Yeah.
Cool. Backlog.
That's actually in progress.
Oh, this is in progress now?
Yeah.
Great. Sentinel hash. Backlog still?
Backlog.
Yep.
Yeah, I like fully do not intend to touch that for like a month.
I took all my minor stuff out too for the same reason.
Backlog as well.
Backlog? Okay.
Yeah.
Some new issues. And sort by newest. All right, that's the PR we just discussed. This bug right here is, I just noticed that on master, this test will sometimes spin forever. I need to find out why and fix it.
Yeah. Do you think we should put like a 10-minute limit on some of these, really just on all of the tests?
Yeah, we probably should.
Because like it is true that these are that like they have non-determinate runtimes, but at 10 minutes, like almost all of them should have long completed, right? Something like that.
I agree.
Yeah.
I can do that. I'll open an issue for it.
Cool. Thanks.
This issue is interesting. It turns out the code for mining blocks doesn't look at how much of the chain state is available before it starts to try to produce blocks.
Yes. So, yeah, I was going to comment on this. I think that this like necessarily has to be something like a heuristic.
Yeah, I agree.
So it's something like, I think it's like if you've downloaded blocks, like it has to like depend on the rate at which you're downloading blocks. Like if you're downloading blocks faster than there are blocks, like let's say you're downloading blocks at like 5 times the rate that blocks should be getting produced, that means that you're very actively syncing and you probably shouldn't try to mine.
Yeah, that's true.
But otherwise, yeah.
At the same time, though, your rate could fall really low if you have like a network level issue.
Yes, but in the event of a network level issue, I think you should be trying to mine.
Even if your chain state's like halfway complete. Like let's say you have an intermittent issue when you're halfway through syncing.
Yeah, I think you should still try to mine. Because otherwise, network issues are like you've turned a network partition into like a availability crisis.
Yeah, that's true.
So question about this, should we spend some cycle on this fix knowing that the mining like it's not the final architecture?
Right. Yeah, that's a good point. That like ultimately, if we are planning on making like our mining algorithm or mining architecture very different, then there's a question of how much time we should even be spending on this. And I guess that depends on how much the mining architecture is changing. Like if the mining architecture is switching to an architecture where like you have a separate miner program that's just like downloading, like assembling transactions or like picking transactions to include and setting the rate that you're paying for your blocks, then we would still want to implement this in the stacks node somewhere.
You'd still want to be able to track the rate.
Yeah. And yeah. Right. At a minimum, like we would want to be able to send data over to the miner binary that like hints at whether or not it should be trying to mine right now.
Is that the case? Because yeah, okay. Like it could be something in the v2/info that tells you, okay, the node is ready.
Yeah. Yeah, so if we put it in V2 info, that would be like one approach. But like we still need to collect the metric. Yeah.
Cool. That's a good idea. So I think this is a separate issue then, like report download rates. The P2P thread, I think, can figure this out just naturally because it already has full insight into this.
Yeah.
As far as investing cycles in this, let's first figure out the rate code, which has to be there, and then maybe from there we can figure out how easy or hard it is to modify the miner.
Yeah. I think that like with the current miner architecture, it would probably be pretty easy. Like we could just have like a function like should mine, and it's just checking the PTP threads metric.
Yep, sounds good. Oh, this is my PR. Never mind. We already talked about it.
Yep.
All right, Hank reported this a few days ago. I looked at the code, and we are inserting a protocol scheme in the observer URL. The endpoint does just expect an IP address, but we don't report anything. We don't report any error messages if the user supplies a protocol scheme.
Sounds good. Can you send that to me?
Sure. Let me do that right now.
Thanks.
This is just a note to change the block reward lockup window to whatever the reward cycle is going to be.
Yeah.
I think we talked about this earlier, Aaron.
Yep.
And I think we talked about the microblock issues last week.
Yes.
Yeah, cool. And same with the merge option.
Yeah, we talked about this a bit last week. Yeah, I think this is a good issue. So.
Yeah, good help wanted issue.
Yeah.
All right. Cool. How are we all feeling about the timeline estimates here?
I think that we might want to revisit like this after our discussion.
Fair enough.
Yeah.
Testnet derivation path. I think we've been talking about this mostly async, but I think we're kind of on the same page. Just use the same derivation path in both testnet and mainnet.
I don't think we're on the same page then.
Oh, okay. Let's talk about it then.
Yeah. I mean, I don't know. I think that unless basically like my default worldview is that like you should follow standards unless you have like a compelling reason not to follow the standard. And the standard for most cryptocurrencies when it comes to their HT wallet derivation is that they use the standard testnet derivation path, which is like a coin type of 1 for their testnet, and then for their mainnet they use their actual coin type.
Oh, okay.
Well, so like, yeah, I agree that it's not that useful for us because we have a different version byte in the transactions. But if it's what people are used to, then yeah.
Okay, I'm on the same page generally. Like, no point in deviating from expectations unless it's necessary.
Cool.
I don't have a strong opinion either way.
Yeah, I don't have a super strong opinion. I think Kyron was going to open a SIP PR for that.
Yeah, I believe he was.
Yeah. And then I have a related question about the current status of SIP reviewing, because I think like SIP 0 describes a process with a lot of mechanics and in particular, like functionaries that don't exist.
That's correct.
And so are we planning on reviewing SIPs in more or less the same pattern that we have been previously, which is just sort of the same, like basically blockchain team style reviews? Or is there like a different interim process that we're thinking about?
I think to use the parlance in SIP 000, I think the three of us are the only SIP editors that exist right now. So we're reviewing SIPs, making sure they're well formed, and we're assigning them a SIP number, and we're moving them into out of draft status and into accepted status.
Gotcha.
So what will eventually happen though, and I guess like we would be part of, but not the entirety of, the blockchain team would form a consideration advisory board for things like consensus and networking and the clarity language and other sorts of considerations like that. And we would provide the technical feedback on, so far it applies to all the SIPs, but I think the one that Kyron will be working on will be a SIP that maybe DevX will have a consideration for that they control.
Yep.
Once we have the steering committee, so to be clear, like none of these SIPs are ever going to be ratified until mainnet launches anyway. And I don't see and for mainnet launching, we don't necessarily need to have them ratified right then and there. We can ratify them after mainnet launches. But once we have the steering committee set up, they can proceed to walk through the activation steps of all the SIPs and determine whether or not the SIPs have been ratified and accepted by the greater community. And the activation section for the current SIPs today, except for the wallet one, but all the other SIPs could just be mainnet launches.
Yeah. That makes sense. Should we codify that somewhere?
Yeah, we need to, as SIP editors, we need to go update all the SIPs so that they conform to the right format. And also they have an activation section that specifically lists the criteria for determining whether or not the SIP was accepted by the community.
Right. I meant the this interim status where we don't have committees yet and like we are sort of functioning as interim editors.
Right. So what we would do is we would list we would just set ourselves up as the first editors.
Oh, I see.
Like all these SIPs are just none of these SIPs are materialized yet, right? They're kind of in staging status. So we would set up the relevant boards and functionaries, and then proceed to move the SIPs through them.
Gotcha.
That's probably that'll happen. Like I'm hoping to get that done before mainnet launches on the foundation side of things.
All right, that makes sense.
Because I think the SIPs aren't going to live, because one of the provisos in SIP 000 is that all of the ratified SIPs will sit in the same GitHub repo as SIP 000. So unless they're there right now, which they aren't ratified, or even drafts. They're just copies that we have.
Yeah.
Okay, so Kyron's going to send us a SIP for the derivation path.
Yep.
So testnet is broken right now. You're saying it's producing a bunch of invalid blocks. I think you got the Kibana graph up here.
Yeah.
Crap.
Yes. And it's his own, like it's the master node's own blocks. So.
Huh.
Yeah. So clearly something is up. We can, yeah, we'll have to dive into what's going on with the data.
Yes. It didn't get a single block.
Not for like 6 hours or something.
But it has gotten some blocks.
Yeah, the chain height right now is like 700.
Weird. Okay.
Yeah.
So after this meeting, I guess we can just go check out the block data on the pod itself.
Yep.
Cool. Do you want to talk about the POX lockup and POX database and where we are with that?
Yeah. So I'm fairly convinced at this point that we probably do not need the POX database, and that in some ways it will be simpler without the POX database.
Let me just pull up the relevant issue right here. This is in.
Yeah, I think that the most discussion in this is happening like at the bottom of your PR.
Oh, okay.
Yeah.
Not that, but sorry. Here it is.
Yeah.
Yeah.
So the biggest thing that the POX database and the like POX identifier and sortition identifier was providing was like a very clear way to figure out whether or not you are currently on the canonical sortition fork, and if you're not, how to find where to like go back to.
Right.
But all of that is doable just using the sortition database.
Because it already has, if we just add these two MARF keys.
Yeah.
Yeah, you can enumerate the set of.
Yeah, or you can test, like after you've processed the stacks block, you can test whether or not it was a POX anchor block that you need to go back to.
I'm sorry, that you need to go back to? I don't know what you mean.
That, so if you process a POX anchor block that you have already processed a ton of sortitions as if that anchor block didn't exist.
Oh, I see. So you're like, at block n plus 100 or whatever, and anchor block for height n arrives.
Yes.
Okay.
And then at that point, like the chain coordinator needs to do its process where it changes the canonical sortition.
I see.
So I think that if we go this route, it may be the case that we need to store the chain coordinators state, like the 3 variables, in a table, like in a SQLite table, because on restart, you want to be able to quickly find the chain tip, which you wouldn't be able to do otherwise.
Sure. The 3 variables, these are POX ID, consensus hash, and, well, actually just consensus hash and block hash, right?
Yeah, I think it should actually just be consensus hash and block hash now.
So for just the anchor blocks you're saying, and those go in the table?
No, so it's just the canonical consensus hash and block hash.
So the table is like the table is almost like a look-aside buffer for the MARF state.
Yes. And it just tells you like which tip of the MARF you need to reopen to.
Yeah, it sounds kind of like the canonical stacks tip database that exists now in the sortition DB.
Yeah.
Yeah, that makes sense. Does this approach? So the one key difference between POX forks and generally speaking other forks is that once a POX fork is ceases to be the canonical POX fork, it also is invalid forever.
Yes.
Does this significantly affect the design of the POX DB in order to check that a fork cannot be built upon?
So sort of. The big impact for that is going to be, I think, in the networking code, and potentially in the chain coordinator, but probably mostly in the networking code. Because when you're accepting a block from someone, if you accept it based on consensus hash and Stacks block header, you want to kind of go back and invalidate all of the consensus hashes that were on a POX fork that went away.
So you would, I'll need to work through how to do that efficiently.
Yeah.
I think it could be done pretty efficiently. But generally, you're advocating that that this test is in the block acceptance test that we put in the networking code.
Yeah, I think so. Because like the network shouldn't be trying to propagate those blocks. Like if it knows they're invalid, we shouldn't be trying to propagate them. And then, when it comes to actually processing blocks, the chains coordinator should be able to pretty easily not process any of those blocks, because like the blocks it's trying to process, well, yeah, it depends on how we write blocks processing code or how much we change it. Because right now the way that we do the process next staging block, basically depends on the staging blocks that have been accepted.
Yes, that needs to be modified so that like, actually, I'm not sure that it would, right? Because you would, well, actually, no, I'm sorry. Yes, it would. You would need to, if the block under consideration is an anchor block, or if you notice that I think you need to sort the blocks, that the order in which you process blocks by their burn chain order, so that you will always process an anchor block before you process any other block that was mined later, but perhaps anchors to an earlier block than the anchor block.
Yeah, I think that's true.
In doing so, you can tell. Well, actually, no. This shouldn't really affect the Stacks block processing, right? Because the Stacks block processing is looking at what it believes to be the canonical POX fork already. So it's not even going to see the winning Stacks block hash for a sortition that is no longer valid, because it will no longer be in the canonical POX fork history.
Right. So I think that there's kind of like two things that will be happening that might affect how we implement the block processing, like the staging consideration, like when you consider a staging block to be processed. So one is if we update the network block acceptance, like the block downloader code, that helps the processing consideration a lot.
Yeah, it was just occurring to me, like the really nice thing about the POX code is that you can always, your criteria is very simple to validate. Like all you have to do is verify that you just compare your POX fork knowledge to the remote node's POX fork knowledge. And if you have a better fork, like you have more anchor blocks, then you can ignore a node that doesn't, full stop.
Right. Yes.
And that's pretty easy to query for. You can even include that in like the message preamble or something.
Yeah. And then the second thing that happens with the staging block consideration is that like, so if you undergo one of these POX forks, and so you had a bunch of sortitions that had block winners that are now invalid.
Yep.
When you ask the staging block database to like try to process the next block, what it will need to do is like when it's querying blocks out of its database, some of those it shouldn't attempt to process. But in order to figure out whether or not it should be attempting to process them, it's going to have to do a MARF query for each of those blocks.
A MARF query against a sortition DB.
Yeah. And so there's maybe some concern about like the runtime of that. But I think that that's like eminently solvable because like if you have a block that's won a sortition that is like invalid, you can like safely remove it from the database.
Yeah, I was just thinking like in the event you have, in the event the chains coordinator needs to go and reprocess a bunch of sortitions, you can tell which accepted stacks blocks will no longer be valid, and you can just mark them then and there as garbage.
Yeah. That might be true. It might not be true. I'm not sure.
Or you can mark them as like you can put them back into staging.
Yes.
But you're right. They aren't necessarily garbage because you could have the same block in multiple POX forks.
Yeah.
And then, so the chains coordinator would just reprocess the sortitions, and then after it processes one reward cycle, it could process the next batch of stacks blocks. And then that way, stacks blocks that are not on the are not on the canonical POX fork can just be discarded.
Yeah.
Yeah, that makes sense. Can you tell me a bit more about how you see this MARF query here on the sortition DB? When processing a staging block, you're just seeing that one of these keys exists.
Oh, do you mean when considering whether or not to process a staging block?
Yeah.
Yeah, I think for that, what you're doing is you're querying the consensus hash.
Yeah.
To find the sortition that has that consensus hash.
Yeah, that's already done without querying the MARF.
But you need to determine whether or not it's in the current fork.
Oh, yes. Yes.
Yeah. So like you can find the sortition ID or however we're identifying the MARF root. You need to find that MARF ID, and then you need to do like the MARF test, like is ancestor block or whatever.
Yeah. Do you foresee the MARF for the sortition DB maintaining just the enumeration of all consensus hashes on the canonical POX fork?
I don't know if it should contain an enumeration of them.
Well, by enumeration, I mean like every time you process a new sortition, you add the consensus hash as a key into the MARF.
Yeah, so we can either do that. We can do that if we are, I think of that as almost an implementation detail. Like if we continue to identify things, if we continue to use like sortition ID as the identifier for things in the sortition database, then one thing we could do is just like look up the sortition ID in the SQLite table corresponding to a consensus hash.
Okay.
And then we could do it that way. Alternatively, we could just add the consensus hash as a key every time we add a new Marf try.
I know it's an implementation detail, but you mentioned you're worried about the performance of it, so I'm just trying to see if there's any way we can speed it up.
Yeah, I think in either case, it's one Marf lookup.
Yeah, that's my feeling too. And if we have this look aside table that you mentioned earlier, this is kind of the same thing as the download header hash cache in my mind.
I see. Yeah, I mean, I was thinking of this as a table with one row at all times. It's like almost like a just like a global variable.
Okay.
Like a persisted global variable.
If we kept the consensus hashes for each and every sortition in the canonical POX fork available somehow, then that saves you the Marf lookup. And
yes.
I agree, those are very expensive to do compared to a SQLite lookup, like a factor of 10.
Yes. So what we could do is maintain a table like that, because that would also speed up it speeds up the block consideration logic significantly.
Yep.
And that table is like super easy for the chains coordinator just to invalidate and then refill if a POX fork occurs.
Mm-hmm.
Yeah.
Cool.
But what we'll probably do implementation wise is do that table, like start that table off as the one row variant, and then turn it into more of a look aside buffer as like an additional whatever performance speed up. Like I don't consider it a correctness requirement.
Oh yeah. We won't optimize it until we're sure it's gonna actually make a difference.
Yeah.
Okay, do you have a better understanding about the database design now, everyone?
Yes, I think the next question though is like, what are we going to work on as a result of this?
Yeah.
So if we look at this testnet timelines and estimates thing,
Yep.
I mean, from this discussion, kind of what it means is that the tracking of anchor blocks is kind of folded into the integration of the chains coordinator.
I'm not seeing the chains coordinator. Oh, I see. That work should technically be done, but maybe it needs to be extended now.
Yeah.
All right. Well, just temporarily doing this here. We can make them all look prettier at the end.
Right. I mean, to a certain extent, what it means is that top one just no longer exists.
This top one, this orange one?
I think so. I don't know. Does that make sense to you, Ludo?
Yeah.
What's about to happen?
Yeah.
Okay.
So yes, delete or no delete?
Yes, I think it makes sense to delete. Yeah.
Yeah.
Integrate chains coordinator is going to subsume the things we just talked about here.
Yes. Except for the networking code.
Yeah, except the networking code.
Yeah.
Okay. I will just make a note of that. Okay. Are we still considering the testing of the anchorless implementation?
Yeah, I mean, on a certain level, I would say that that is the same thing as integrating the chains coordinator.
All right, so
that is just like part of that process.
Consider that a parallel effort here then.
Yeah. Determining the recipient set and sortition using the recipient set are not parallel processes.
So are these going to be strictly sequential after the change coordinator?
I think that those are, yes, strictly sequential after the change coordinator and the stacked lockup state.
Yep. Oh, so the lockup state has to happen. I mean, I think that can happen almost in parallel.
I agree. Yeah, so the lockup state and the recipient set are, yeah, those are perfectly dependent on one another.
Yeah. I'm going to be just generous and move some stuff around here. We can shrink them later.
Yeah.
Speaking of lockup state, I can tell you where I am right now on this, and maybe I'm accidentally duplicating some of your work, but I haven't done very much. So far, it's just a Clarity contract. I can actually pull it up maybe somewhere.
Yeah, I mean, I don't think that there's probably any work duplication going on. I think that there was, so Ludo asked some questions, had some questions for me on Friday related to the lockup state.
Mm-hmm.
So like specifically when determining the recipient set, in a certain sense, you have to be able to iterate the lockup state.
Why do you have to iterate it?
Because like you need to be able to determine a reward address. Like you're choosing a reward address through random selection, right?
Yes. So I can think of a couple ways to do this. That's actually an interesting requirement. So because we will, we already know the contract, right? We know the contract ID. We know this method signature. We know the structure of its state. We could just add we could modify the block processing code so that if it sees a contract call into the stacking code, or it sees a Bitcoin transaction that has the same effect and has to materialize state in the stacking code, we could separately maintain a SQL table, right, of all the addresses for a particular anchor block. So that way we could expose it via an API endpoint, for example.
Yes, so I think that the tricky thing is that it needs to be somewhat fork aware.
Yes, I agree. It has to go into the headers DB.
Yeah.
But it's still iterable then.
Yes. So one thought I had was that we could try to make this iterable in the Clarity contract by like creating pagination in the lockup state. The advantages of this are that, you know, we're dog fooding pagination and Clarity. We demonstrate a canonical use case for pagination. And then in addition, we get the sort of like fork awareness for free in a certain sense. It's not free, but yeah.
Can you describe a bit more about how you see the iteration working?
Yeah, so basically what you need to have is a map from positive integers to lists of lockups.
And what are the positive integers?
The positive integers are just, page number. And so when you add a new lockup, like you pay for the pagination.
Oh, okay, yeah. So this is just like a simple, almost like a linked list. You can just walk back
Yeah,
and you just keep the tip, the latest tip as a data var or something.
exactly.
So how does that work if I'm acquiring like a paginator and then the list is being updated by another transaction?
Right. So we probably need to do compaction on the list every so often, like every 1,000 blocks or something. Like compaction needs to occur.
Who pays for that?
In our contract, I think that we can just have the miner pay for it. Like we can make this a sort of special operation or something like that. But usually it would be whoever submits a transaction that results in compaction.
In general, though, who would pay for compaction?
I mean, in general, it would be, yeah, if it's a Clarity code being executed, like
You
it
that
would
calls
be,
it, yeah.
yeah, whoever calls it, yeah.
Is there a way we can, I guess a couple of questions come to mind. First, do we need to do compaction? Like, is there an alternative data structure? The reason I ask is because in Clarity, you can't do unbound iteration anyway.
Right. It's possible. The issue is just that the reason that compaction is probably necessary, or I mean, compaction would be nice, is because everybody can have different lockup times. One second.
Sorry, I know we're at time, so if y'all have to break, we can just keep this going asynchronously.
Good. I prefer yeah, continuing the meeting. But yeah.
Okay, I can stay on too.
Yeah, same. Yeah, so because everybody can have different lockup times, what it means is that you could have entries in your lists that become invalid before one another. Like the only reason you're removing items from the list is because the lockup has expired.
Yeah, and you're reclaiming your stacks.
Right. So like one alternative to compaction would be to just clear the list every 12,000 blocks, or like move the head of the list forward every 12,000 blocks. Because no lockup can go longer than that.
Yeah, but I can stagger them, right?
Yeah. But either way, like you would move the head forward.
So, I mean, this is, I just thought of a separate approach at the same time here.
Yeah.
We like some sort of bucketing scheme. But this kind of also is getting at another related question of like, how much, what are we trying to do here? Like how much interesting algorithm work do we need to express in Clarity? Like if we're just trying to make it so that we can get the reward set every reward cycle, and this is kind of a built-in feature of the chain anyway, do we need to try to do this in Clarity? Because it seems like we could find ourselves, penalizing people or having to do some sort of special case handling anyway. Like you said earlier, like having miners pay for compaction.
Right. I'm not sure. I think that like the way that I think about this is like, if it is not overly burdensome to us to do it in Clarity, then we probably should just as,
Yes.
Yeah.
No, I'm sorry. I didn't mean to cut you off. I'm just enthusiastic.
Yeah. Like if we can, we should is the way that I think about it. But if we're facing like a ton of difficulty with trying to do this in Clarity, then we should like make a note of like why that is, and then not do it in Clarity.
Well, let me ask this a little bit differently. When I saw your proposal earlier with pagination, do we foresee Clarity code itself doing the pagination? Like, will I ever have smart contracts have to iterate through the map? Because I think the answer to that kind of tells us how much effort we need to put into this in Clarity. Because right now it looks like the only people who will be doing the iteration through the lockup addresses is the POX code, or some sort of API downstream outside of the node and outside of Clarity that consumes it.
Right. Yeah, so that's the case. And I think that's sort of why I'm like, I don't feel that committed to saying that we should be doing this in Clarity, because I don't think like other callers are going to be trying to iterate.
Right.
Yeah.
There's another alternative here, and that is we could implement a way to do iterable data maps in the MARF itself that are not part of the consensus code, but they're just like a secondary index over subsets of the MARF key value pairs, like say over all the contracts or over all the particular entries in this particular map that could be used for something like this. And that's way more general and would also allow someone to set up particular indices for like an explorer. But I think we talked about this a long time ago in the design of the sidecar though, and decided against trying to do that right now, but maybe this is forcing our hand. I don't know.
Yeah, I mean, I think we should think about it. I think we should think about how we can make this a more general structure. Like if we want an iterable structure in the MARF, then we should certainly be trying to make it general. And if we make it sufficiently general, then we should try to add support to Clarity for iteration as a first class idea. I think that the actual structure of this in the MARF is either in fairly algorithmically complex. Like there's things that we could do with like something like a skip list kind of structure where, something like a skip list structure. But I think that that'd be very algorithmically intricate.
Yep.
Or we could do something a little bit stupider that looks like pagination.
Yeah, I wasn't, I don't think you'll need a skip list because I don't think you need to have any sort of, we already have a fast random access mechanism for the MARF, and that's O1 as opposed to O log n. All we would really need is just like, given this key value pair in the MARF, what is the hash of the next key value pair in this collection?
Yes, so the problem is, so that's like the pagination scheme.
And right, but it's at the MARF level here.
Right, but what you would want to do is somewhat bucket them.
Yes.
So that you would be able to like fetch a group of keys all at once, rather than having to basically do a MARF lookup every step of the iteration.
Yeah, you would almost yeah. This could get intricate too. I don't think you would do page numbers. I think you would do some sort of cursor. Yeah. So it would be like a one directional scan.
Yep.
Do you, that said, like if all we need from the Clarity implementation is a one directional scan to get the set of addresses, do you think that's sufficient? Because I think that's actually easier and simpler to represent.
Yeah, I think that's, I think we only need a one direction scan.
Because that's way easier to build into a map. You just have each row in the map point to its ancestor.
Yes. Hmm. Yeah. I mean, there's even schemes that don't require a new Marf lookup every step. All right, so if I look up a Marf key
Uh-huh.
and I have the value is stored in a database, right?
Yep.
And these things are all content addressed.
Mm-hmm.
So if the row in the SQLite database has the pointer to the previous item in the linked list,
Yep.
then I don't need to do a Marf lookup at all. The
No.
pointer could be a content addressed pointer.
You would just need to do pointer maintenance whenever you insert new things. Actually, no, you wouldn't, because it's append only.
Right.
But you would need to have some sort of, this could get hairy if you have a sparse map though, right? Like
Yes.
if you have a lot of keys that were deleted.
Yes, it would get very hairy if you did deletion.
And we kind of sort of do that in
Yes.
POX a lot.
Yeah. Yes.
In fact, the POX map is going to be mostly empty cells.
Correct. But yeah.
But if we did this sort of thing, I mean, like, performance aside, if we did pointer maintenance in the Clarity map, we could get that for free, skipping over empty cells.
Yes.
It's just that each time you walked back from one row to the next, that's a Marf lookup, at least one Marf lookup.
Right.
But I think I think the minute we start to think about trying to iterate through reward addresses just in Clarity, we've already resigned ourselves to doing a crap ton of Marf lookups.
Yeah.
Like literally O of the number of addresses.
Yes.
If we're okay with that, then we should just do the Clarity approach. I agree. It's way safer. It's way less intricate and thus easier to reason about. I just don't know what the performance is going to look like.
Yeah. I mean,
but it's also like a one hit, right? It's like you only do this every anchor block. You don't do it all the time.
correct. So you only do it every anchor block, which makes me maybe, yeah, I don't know. At this point, I'm just like guessing like which is going to be more expensive. Like I suspect that it will be more expensive to do all of these Marf writes.
It's who's writing?
To do this maintenance in the Clarity code. Yeah.
Yes, it'll be expensive, but I mean, that's covered by the transaction fee. Like that's,
yes.
We bill people for that.
Right. I guess actually it's the Marf reads at the anchor block. So we're going to do like O of however many addresses have locked up reads.
Yeah, and that's the best case.
That's the best case. I think that will be more expensive than doing this like search through the database, like through SQLite.
Oh yeah, like it's like a 10x.
Yeah, like even with the fact that you're doing like excessive work, because like there's going to be entries that you're going to have to pass over that have expired.
Yep.
So that's like sort of the direction that I would be leaning.
At the same time, like it's not all Clarity transactions that will be modifying this table. We also have Bitcoin transactions that need to be translated into direct inserts into this map here.
Yeah, I mean, the way that I think about implementing the Bitcoin transactions right now is like in a perfect world, you would read the Bitcoin transaction and then like translate it into the Clarity contract call that it would have been.
Yeah, precisely. From what I have here so far, like if I'm processing stacks block N, I look at for the Bitcoin transactions in the anchor block that selected stacks block N-1, which could be the previous anchor block, but it could also be like, 100 Bitcoin blocks back or whatever. and then I apply those as part of the block processing.
Yeah.
That way it shows up in all of the stacks blocks that descend from that stacks block that process them, as it should.
Yeah, I think that's right.
And also the miner has all the information it needs to produce a valid anchor block, because it would just find the parent stacks blocks burn block, pull out its sortition information, and then process the stacks lockup transactions as part of making the block.
So I had a question about that. Is there a way to generalize this action of modifying the stacks chain state from a Bitcoin transaction?
I don't think so. I mean,
because
okay,
it
so
looks
let
like,
me unpack that. Like, yes, we could find a way to encode a contract call as a Bitcoin transaction. But I don't think that we'll be using it for anything besides a handful of specialized use cases like this.
yeah, because it looks a bit like a sponsored transaction somehow. Yeah.
Yeah, I mean, it's certainly it bears a lot of similarities. I would hesitate to say it's the very same thing, though. Like the invalidation path, for example, I think is a bit different. Like if you send a Bitcoin transaction that is invalid and that would do something like try to spend tokens you don't have, then the error handling is going to be necessarily different. Like you shouldn't invalidate the stacks block because the Bitcoin transaction was bad. You just ignore the Bitcoin transaction at that point.
Mm.
Whereas if it were a stacks transaction that spent money that you didn't have, the whole block is invalid.
Cool.
But either way, it seems like the biggest design issue right now is how do we figure out getting that reward set from the lockup state.
Yeah, and I think we've got some good options, I think, or at least promising options.
Do you want me to take that on as part of implementing the lockup state?
Sure, if you, yeah, I mean, it's probably most related to the lockup state in terms of like the current workflows. So yeah, if you want to work on that, go for it.
Cool, let me just go make a note then in the specific issue here.
And then Ludo, are you gonna work on the wire format stuff?
Sure, yeah.
How much work have you
some...
done on POXDB?
So it was really my first time interacting with the database in general, so I spent some time looking at the mechanism. Then I had the POX ID with like the bit vector working.
Okay.
And then I was working, yeah. So I initially didn't saw the task. Like I didn't know that we had a task for determining the recipient set. So I was just working on unstubbing everything in the POXDB struct. And so I started working on that. And then I saw that I had to get an idea of what the POX contract would look like. So I also did a draft of the POX contract, which led me to spot this enumerable list issue. So yeah, I have like a lot of drafted things in progress, but
yeah, I think yeah, I mean, I think that we still need the POX bit vector because that's going to get mixed into the consensus hash every 1,000 blocks or something. But yeah, we can I guess we can sync offline
Mhm.
about, yeah, what to do with the draft stuff.
Yeah, my guess is that it's been rewritten somehow
I see.
in the other PRs.
Okay.
But yeah, happy to take on the wire format. Do we have a spec somewhere? Oh,
I don't think so.
okay.
I think the closest to a spec is the description of just like what goes in the messages in the
Because
set.
I think so by wire format, are we talking about the transaction, the Bitcoin transaction?
Yeah, I think so.
Okay.
Aaron, just it's relevant to the wire format. To confirm, the Bitcoin transactions will need to include the latest stacks chain tip that the clients currently see, right?
Yeah.
That's not the anchor block. That's just the latest, whatever descendant of the anchor block exists.
Mm-hmm.
Does that also mean that the stacks transactions for locking up stacks do not need to consider any sort of chain tip at all? Because necessarily, like,
Yes.
the chain tip their client sees is the one that the transaction gets mined in.
Correct. I mean, well, that's not true.
Okay, so you just put the chain tip of the penultimate block.
Yeah, you just put the chain tip of whatever your client sees, you put the chain tip in. Like even in the stacks transactions, I think the usefulness of it in the stacks transactions is probably pretty low.
I was gonna say, like, we don't know how to validate this.
Right.
So it's just
I think
data,
that,
right?
yeah, I think that it's like we would need to have two validation paths, one for the broadcasted on the stacks chain transaction and one for the broadcasted on the Bitcoin chain transactions.
But I think the validation either way happens once the registration cycle finishes, right? Like, it doesn't happen right then and there.
Yes.
Yeah, that was throwing me for a loop this weekend.
Yeah, because it's like you're trying to count basically votes in support of an anchor block and then like clearing a threshold.
Yes.
So, yeah.
But nevertheless, though, the lockup when broadcast on the stacks chain, these messages must be confirmed on the stacks chain before the anchor block for the reward period.
Yes.
The chip that the stacks transaction is going to include is going to be an ancestor of the anchor block then, right?
Exactly. So like those need to be, yeah, they like provide a very different property than
That's
the
very
ones
different
on
information than what the Bitcoin chain produces.
Yes, it's very different information. Like the Bitcoin chain is producing like actually like I have seen the anchor block.
Right. Whereas the stacks transaction is like I have seen an ancestor of the anchor block.
Right. So like we need to treat those pieces of information differently.
It's unclear like how the but that's just the thing though. Like if the criteria for activating the reward cycle is that 80% or more of the locked stacks, quote unquote, bless the particular anchor block, it's not clear how putting an ancestor of the anchor block as your preferred chain tip does that.
Right. Yeah. I agree. Like I think that yeah, this requires some thinking about. I mean the threshold of support for like blessing, I think was much lower than 80%. Like I think that we were thinking, yeah, like 10% ranges. Yeah.
But I mean,
don't know.
Yeah, but I mean, stacks transactions don't really add anything there at all.
Right, they don't add anything at all. I agree. So we probably need to think about this. Like if there's some kind of scheme we can come up with where they're providing some value.
Yeah, because the design of SIP 007 requires stackers to be able to preempt miners from doing bad things.
Yes.
Okay, add that to the list of things to think about.
Yeah.
Could we, I mean, a really straightforward solution here could be like you only send your stacks transactions during the registration phase and not prior. Right? Because then you do bless an anchor block.
Sorry, say that again?
So right now, SIP 007 as written says that you can send your stacks lockup transactions at any point in time. Or there's no constraint over when you can send them and have them accepted to lock up your stacks for stacking. But if we altered it so that you could only send your stacks lockup transactions during the 250 block registration window, then you would be obliged to bless the anchor block.
No, because the anchor block occurs before the registration window.
I thought sorry, maybe I'm mixing something up here. You have every POX reward cycle starts with the anchor block, right?
No, so the reward cycle is like starts 200 and at a minimum 250 blocks after the anchor block. So the reward cycle basically is this, or the pre-prepare phase is basically this period of time that gives you enough of a buffer to have like seen the anchor block and everybody to have built on top of it. So like for an anchor block to have been selected, like it has to be an ancestor of 80% of the blocks in the prepare phase.
Right, but isn't that what I just said though? The state of the chain for a particular reward cycle is anchor block, then 250 blocks, and then 1,000 blocks of paying rewards, right?
Yes, but all of the information that goes into the reward set has to like have been included in that anchor block.
So there, I guess I'm proposing a change then. What if the block that selects the reward set is the block that's 250 blocks lower, or 250 blocks after the anchor block?
The problem is that you don't want to depend on any information in the stacks chain state that occurs after the anchor block. Because then like the block missing or arriving is very problematic.
But then there's no way for stackers to bless an anchor block if they have to get all their transactions in before the anchor block is mined.
Yeah, I think that's true.
What if the act of locking up stacks were separate from the act of blessing a chain tip? Like you do two things. You commit your stacks before the anchor block is mined, and then you bless an anchor block after the anchor block is mined. And that's what gets the ball rolling.
Yeah, I mean, that's possible. You would still want it to be the case that you're doing this blessing on the Bitcoin chain. So like really what we're saying is that like we need to have this additional information from the Bitcoin chain, because that's giving us a better ordering of like what all is happening in the system.
Why does it have to be on the Bitcoin chain?
Basically, in no case, like, do you want to depend on data in the Stacks chain for this choosing what's a valid sortition or not, unless it's been confirmed a ton of times. Like all of the work that we're doing to pick an anchor block is because we don't want to depend on data broadcast on the Stacks chain that hasn't been sufficiently confirmed. Like even if you separate the lockup from the blessing, like the fact that the blessing has an impact on whether or not the anchor block is going to be selected means that like if you don't happen to see that block, it will change your view of the proof of transfer state.
But isn't that what we want though? Like if you see a slew of Stacks transactions that each bless a different anchor block in the, in the extreme case, shouldn't that be sufficient cause to not do POX rewards?
But the problem is that all of these things, like if you are just so happen to miss a block, then you're going to process that anchor block as if it was chosen.
If you miss a block.